All right, let's take a look at the projectile problem where you don't know the angle here. So angle theta, and shot at 90 meters per second. It's going to drop 30 meters, and it's going to land 60 meters from the base. As before, we set up horizontal and vertical. So horizontal and vertical. I have displacement, initial velocity, final velocity, acceleration, and time. I know horizontally it's going to end up 60 meters, so let's make those my positive directions. I'm going to go I hat and J hat using traditional notation, so this is I hat and J hat. So it's 60 meters. It's going to, since up is positive and it's dropping 30 meters, this is negative 30 meters. My initial velocity horizontally is 90 times the cosine of 90 meters per second times the cosine of theta, and this is 90 meters per second times the sine of theta. My acceleration horizontally is 0 meters per second and negative 9.8 meters per second squared. Again, this is the hardest of the projectile motion problems in my opinion, and there are a couple of ways of solving it. So we're basically going to be plugging into that the displacement is equal to initial velocity times time plus 1/2 at squared. We can use this constant acceleration equation because the acceleration is constant, as is demonstrated right there. So we have the horizontal equation. So 60 is equal to 90 times the cosine of theta times time plus 1/2 negative 9.8 times time squared. Oops, sorry. Need to edit that out. So horizontally, I have 60 is equal to 90 times the cosine of theta times time plus 1/2 0 times time squared. That's plugging in the horizontal data. Vertically, we have negative 30 is equal to 90 times the cosine, 90 times the sine of theta times time plus 1/2 negative 9.8 times time squared. We have two equations, two unknowns. So I'm going to solve for time in the first equation. I know that this equals 0, and so time is equal to 60 over 90 cosine of theta. Now, since I'm going to be writing cosine to sine a lot here, I'm just going to use a substitution. So I'm just going to let C equal the cosine of theta and S equal the sine of theta. Since I'm not putting units over here, there should not be a confusion with seconds, and we're not really using C for anything at the moment. So plugging that into here, I get negative 30 equals 90 times the sine times time, which is 60 over 90C. Again, S for sine and C for cosine, plus minus 4.9 times time squared. So this is 60 over 90C squared. Now we can simplify some stuff here. I know 60 goes into 90, that's 2/3. And so we end up with negative 30 is equal to 60s sine over cosine minus, well, this is 2/3 squared and then a cosine on the bottom, so over cosine squared. And so 4.9 times 4 is 19.6 over 9, because that's the 3 squared. And this 19.6, that's 4.9 times 2 squared, which is times 4. And so now we have this. If we solve it for cosine, in terms of cosine here, I want to isolate sine. You get sine by itself, substitute in for cosine, or we'll just try that again. So if I want to get it all in terms of cosine, then I'm going to basically solve for sine, square it, because I know that cosine squared plus sine squared is equal to 1. And if you don't believe that or are not experienced with it, take any angle, doesn't matter which one, take an angle, find the cosine square times the sine square, add them together, you'll get 1. So I need to get this over to the other side. Again, I'm isolating sine right here, so I need to get everything else to the other side and then strip away the parts. So this becomes negative 30 plus 19.6 over 9c squared equals 60s over c. Then we'll bring it up and hopefully go for a darker marker. So I have 19.6 over 9c squared minus 30 equals 60 sine over cosine. I'm isolating c, so I'm going to multiply both sides by cosine over 60. The 60 and the cosine will cancel out on this side, but not over here. So I get 19.6 over 9c squared minus 30 times c over 60 is equal to the sine. If I distribute, I get 1960 or 19.6 over 540 c, because that one of those cosines will cancel out with that, minus c over 2 is equal to sine. Now I square both sides. So I get sine squared on the right, which is 1 minus cosine squared. Again, over here, sine squared would be 1 minus cosine squared if we brought that over. And so I have this whole bit squared, so 19.6 over 540 times the cosine squared, minus 2 times this, 19.6 over 540 times cosine over 2, this one, plus cosine over 2 squared equals 1 minus cosine squared. This, and now we can cancel some stuff out. That 2 and that 2 cancel out, that cosine and that cosine cancel out. So I'm now left with, and I'll have to edit this out. Of course, I'm married to the edge. I am right near the edge. So I have 19.6 over 540c, let's keep that separate, squared times 1 over cosine squared, minus 19.6 over 540, plus 1/4 c squared equals 1 minus c squared. So all I did was to square that one, and dividing by 2 same as multiplying by 1/2. So that's where I got the 1/2 c, and then square it to get 1/4 c. I want to get everything together, so I'm going to bring the 1 over. I'm going to bring the c squared over. And so I'm left with 19.6 over 540 squared times 1 over c squared, minus, subtract 1. So that would be 559.6 over 540 plus 5/4 c squared. Basically, when I'm subtracting 1, I get negative 19.6 over 540 minus 1, get a common denominator. So it's negative 19.6 over 540 minus 540 over 540, and you get this. I have 1/4 c squared here. I'm adding 1 to it, so 1 1/4 or 5/4. And that equals 0, because I cleared off the right side. I'm now going to multiply everything through by c squared to get it into a more familiar form. And so I have 19.6 over 540 squared minus 559.6 over 540 c squared plus 5/4 c to the 4th equals 0. This is a quadratic form. Basically, I can solve for c squared. So this is, if I think of, let's make a substitution of x is equal to c squared. So this becomes, and I'm going to change the order around, I get 5/4 x squared minus 559.6 over 540 x plus this 19.6 over 540 squared equals 0. Now I solve for x. So using the, let's erase this part. So using the quadratic formula, x, which is cosine squared, is equal to 559.6 over 540. So it's negative b plus or minus the square root of b squared. So negative 559.6 over 540 squared, that minus sign is irrelevant there, minus 4 times a, which is 5/4, times c, which is 19.6 over 540 squared, that number right there, all over 2 times a. And the two answers that I got when I worked it out were x equals cosine squared equals 0.827763803184, or two solutions, 0.01273233856. So my cosine, if I take the square root, I get 0.9. So this is the cosine of theta, is 0.90981525772, or 0.0356824026097, which translates into 4 possible solutions, because when I do the arc cosine in trig, the cosine is basically the x value. You have a unit circle right here. The cosine of the angle is the x value if the radius here is 1 of that circle. And there's going to be 2 angles, first and fourth quadrant, which will produce these cosines. Now your calculator is only going to give you one value. Your calculator is going to give you the first quadrant angle, but there's a fourth quadrant angle also. So theta for the first one is plus or minus 24.520 degrees, and the second one is going to produce plus or minus 87.955 degrees. Now, how do you know which is the correct one? Well, there's a certain amount of sense on this. That 87.955, you're practically throwing it straight down. Negative 90 degrees would be like this. Negative 87 is not too far from it. It's not going to go 60 meters. So through thinking through it, that positive solution is the correct one. But which of these is the correct one? And it actually ends up being the negative. And we can check it quickly enough. Well, we can check it by doing the substitution here. So if we go with negative 24, so if theta is negative 24.955, yeah, nope, wrong one, 0.520 degrees, then my initial vertical velocity, well, you pull out the handy dandy calculator, make sure you're in degrees. So 24.52 negative sine 90 times. And so this ends up being negative 37.350977 meters per second. And over here, this one, 24.52 cosine 90 times 81.88348. Given this horizontal velocity here, or the horizontal component of the velocity, since it's not changing, acceleration is 0, we can figure out how much time it's in the air. So 60 divided by that, and we get the time being 0.73275 seconds. And then we come over here and we can figure out at what time it gets to that position right there. So I know that delta S is equal to VIT plus 1/2 AT squared. So we want to check out at negative 30, is that equal to negative 37.351 times 0.73275 plus 1/2 times negative 9.8 times that 0.73275 squared. So we're assuming the negative solution, well, I happen to know it's right, but we're assuming the negative solution and we'll plug it into it and see if it matches. Does it work out this way? So this right here is negative 27.36887 minus, so that would be 4.9.73275 minus 2.63092, and I get negative 29.9998. So a rounding difference. Now if we assume the positive solution, so theta being positive here, I use the magic of the marker, that angle is positive, then that's positive right there, which means it's being shot up into the air. The time is still the same, but the difference is this is now a positive number, which makes that positive, which now makes this, well, a positive number instead of a negative number. So this, the positive angle cannot be the solution. The alternate way of doing it is with tangent. And so, well, it's recorded, so pause it if you need to, but I'm going to erase and do it a different way. So this was an equation we had earlier. If we divide everything by cosine squared, cosine squared divided by cosine squared is 1. Sine squared over cosine squared is tangent, so I'm going to use a capital T for that since I have a lowercase t for time. That's tangent squared is equal to 1 over c squared. That was a mistake I made in class, is I had an extra negative sign in there. So this right here becomes negative 30 is equal to 60 times the tangent. And just as a reminder, the tangent of theta, I'm letting capital T be the tangent of theta, which is the sine of an angle divided by the cosine of an angle. And check it out on the calculator if you're not familiar with this. but I also did in class to show that this is true. Minus 19.6 over 9 times 1 over cosine squared, which is 1 plus tangent squared. So I now have negative 30 is equal to 60t minus 19.6 over 9 minus 19.6 over 9t squared, distributing. It is a quadratic equation, so I need to get it into form to use the quadratic formula. So I'm going to take everything over to the left side. So this becomes 19.6 divided by 9 times squared minus 60 times time plus 19.6 over 9 minus 30, which equals 0. Again, added this to both sides, added that to both sides, and subtracted that from both sides. So this is 2.17 repeating times squared minus 60t minus, this was 27.83, 82 repeating. So my tension is 60 plus or minus the square root of negative 60 squared. Again, the minus sign is going to go away when I square. Minus 4 times 2.17 repeating times 27.82 repeating over 2 times 2.17 repeating. And if you work through that, you have the tangent, which is the tangent of theta, is equal to 60 plus or minus 61.986792 divided by 2 times 2.17 repeating. So the tangent of theta, we have two answers here. 28.007 or negative 0.45615. And that would translate into an angle being 87.955 degrees or negative 24.520 degrees. So if we did the tangent way, which is shorter mathematically, you still have to use a quadratic, the negative pops out of it. But if we use cosine or sine, if we'd done sine, the same thing would have happened, that we would have had to either think through it or do a quick check to make sure that whether the positive or negative solution is accurate. Here we don't have the plus or minus issue because tangent is positive in the first and third quadrant, and it's not a third quadrant. First quadrant is this way from that point of view. Fourth quadrant, second quadrant, third quadrant. Tangent is positive in the first and third quadrant, and the thing is not being shot that way. It is negative in the second and fourth quadrant, and the second quadrant is this way. It is not being shot that way. So it must be being shot downwards. So that is what I tried to do in class, but apparently made a careless error, and it just happens.